హాయ్ ఫ్రెండ్స్, నేను ఇప్పుడు చెప్పబోయే టాపిక్ క్వాంటమ్ నెంబర్స్ అండి. క్వాంటమ్ నెంబర్స్ అనేవి 10th క్లాస్ లెవెల్లో కానీ, ఇంటర్మీడియట్ లెవెల్లో కానీ అండ్ జేఈ ఎగ్జామ్స్లో కానీ చాలా ఇంపార్టెంట్ అండి. కీ రోల్ ప్లే చేస్తాయండి ఇవి. సో కాబట్టి ఇంటర్మీడియట్లో కానీ 10th క్లాస్లో కానీ అయితే ఇవి ఏకంగా 8 మార్క్స్ క్వశ్చన్స్ అండి ఇవి. అది ఇంకా జేఈ మెయిన్స్లో కూడా అయితే క్వశ్చన్స్ వచ్చే అవకాశం ఉంది ఇంటి నుంచి కూడా మ్యాక్సిమం. సో కాబట్టి ఇప్పుడు ఈ క్వాంటమ్ నెంబర్స్ గురించి చూద్దాం. సో క్వాంటమ్ నెంబర్స్ అంటే ఏంటి? ఓకేనండి, క్వాంటమ్ నెంబర్స్ అంటే ఏం కదండి. ఇప్పుడు మనం ఎలక్ట్రాన్ అనేది ఫైండ్ చేయడానికి అండి. ఎలక్ట్రాన్ అనేది ఫైండ్ చేయాలి ఎక్కడ? యాటంలో. ఎలక్ట్రాన్ అనేది యాటంలో ఎక్కడ ఉందో ఫైండ్ చేయడమే క్వాంటమ్ నెంబర్స్ అండి. ఓకే, ద క్వాంటమ్ నెంబర్స్ క్వాంటమ్ నెంబర్స్ describe the position of an electron around nucleus in orbital in orbit in an atom. ఓకేనండి. సో quantum numbers are the quantum numbers describe the position of an atom, an electron around the nucleus in orbit an atom. ఓకేనండి. సో పొజిషన్ ఆఫ్ ది ఎలక్ట్రాన్ by using quantum numbers, how to find the position of the electron mainly. ఓకేనండి. సో how to find the position of the electron by using the quantum numbers. ఓకేనండి, that is the main identity of the quantum numbers and this is the main identity of the quantum numbers and to find the exact position of electron in atom. ఓకేనండి. సో ఫర్ దట్ there are 4 quantum numbers and to find the exact position of the electron in atom here have 4 quantum numbers and there are 4 quantum numbers. There are 4 quantum numbers and one principal quantum number. Two angular momentum quantum number. Three magnetic quantum number. Four spin quantum number. These are 4 quantum numbers and to describe the exact position of the electron in an atom. Okay nandi, now how to discuss about one quantum numbers, okay nandi, in detail. Okay nandi, now discuss about first quantum number, spin quantum number. Okay nandi, it is denoted by letter small n nandi, denoted by letter small n. Okay nandi, proposed by the principal quantum number proposed by Niels Bohr. Okay nandi, denoted by small n and proposed by Niels Bohr. Next, in quantum number values of principal quantum number n is equal to 1, 2, 3, 4 and so on. These are natural numbers. like natural numbers like natural numbers and 1 2 3 and so on. Okay, these are named as these cells, these values named as and k, these are the values of cells and the name of the cells, the name of the cells k, l, m, n and so on. Okay అండి, for example here look at here all of you, n is equal to 1, n is equal to 1, it is a k shell, n is equal to 1 k shell అండి. n is equal to 2 l shell, n is equal to 3 m shell, n is equal to 4 n shell, n is equal to 5 o shell. Like look at here all of you once, it is nucleus అండి, this nucleus around cells are like this. Okay, look at here all of you, n is equal to 1 k shell, n is equal to 2 l shell, n is equal to 3 m shell, n is equal to 4 n shell. Okay nandi, this is like. Okay, now the maximum number of electrons in shell, the maximum number of electrons in shell is equal to 2n square, it is equal to 2n square. Okay nandi, so for example n is equal to 1, n is equal to 1, here number of electrons are 2 into 1 square is equal to 2 only, so 2 electrons, n is equal to 1, how many electrons are there in n is equal to 1? 2 electrons are there, 2 electrons, n is equal to 1, 2 electrons, in n is equal to 1 2 electrons in there. Next, if n is equal to 3 2, n is equal to 2 into 2 square, 2 into 4, so 8 electrons, 8 electrons, n is equal to in 8 electrons, and here 8 electrons. Next, in n is equal to 3, 2 into 3 square, 2 into 3 square, 2 into 9, 18 electrons, 18 electrons, so n is equal to 3 in 18 electrons. Okay nandi, next n is equal to 4, 2 into 4 square, 2 into 16, 32 electrons, 32 electrons, 32 electrons in it. Okay nandi, now by using the principal quantum number, how to find the size and energy in it. Okay nandi, the main significance of the this quantum number is by the using this we find size and energy, we find size of the orbital and energy. So the size of the orbit is n square h square by 4 pi square e square m k z, and energy of the electron in orbit minus 2 pi square e power 4 k square z square m in by n square h square. This is size and energy formulas. And also this quantum number, by using this quantum number also how to find the number of orbitals, number of orbitals in orbit. in orbit is n square. Is n square. For example, n is equal to 1. N is equal to 1. 1 square means 1. It is a here 1s orbit is there. 1s orbital is there. Like that. N is equal to 2. 2 square. It is 4. Here 2s and 2px, 2py, 2pz. Here like that 4 orbitals are there. And n is equal to 3. 3 square. It means 9. 3s, 3px, 3py, 3pz, and 3dxy, 3dyz, 3dzx, 3dx square minus y square, 3dz square orbitals are there. Like this, totally 9 orbitals are there. 9 orbitals are there in it. Like this, you have to find the number of orbitals in orbit by using this quantum number also. Next quantum number, how to find the next quantum number is azimuthal quantum number or magnet is angular momentum quantum number. Okay, nandi. Next quantum number, angular momentum quantum number and azimuthal momentum quantum number. Azimuthal quantum number. Okay, nandi. It is denoted by small l and proposed by Sommerfeld. Sommerfeld. So L value always depends on L values depends on n values. The total n values are total L values L is equal to n minus 1. So the L values are 0, 1, 2, 3 and so on. Whole numbers. Like whole numbers. Okay, Nandi? Now look at that. N is equal to 1. N is equal to 1. N is equal to 1. 1 minus L value is n minus 1 kada. Okay, Nandi? So L is equal to 1 minus 1. Now its value is L is equal to 0. L is equal to 0. Now it is become as S orbital. S orbital. It become as S orbital only. Now next, if n is equal to 2, if n is equal to 2, L is equal to 2 minus 1. Now L is equal to 1. Now it become as a p orbital. Become as p orbital. Next, if n is equal to 3, if n is equal to 3, L is equal to 3 minus 1. Now it is L is equal to 2. Now it become as a d orbital. D orbital. If n is equal to 4, if n is equal to 4, L is equal to 4 minus 1. 4 minus 1. L is equal to 3. Now it is become as f orbital. F orbital. Okay, Nandi. By using azimuthal quantum number, the azimuthal quantum number denoted by L proposed by Sommerfeld. Values are depends upon L values are depends upon N value. So the total values of L N minus 1. Why it is because of dependence on L N value. Here L is the formula of L is equal to N minus 1. Now find the L value. How to know the N value? That's why L value depends upon N value. Now the total values of the N 0, 1, 2, 3 and so on, these are like whole numbers. That's why now find N is, if N is equal to 1, L is equal to N minus 1 formula by using this formula. So L is equal to, substitute to N value is 1. Now N minus 1. 1 minus 1 is L is equal to 0. No, L is equal to 0 is S orbital. Now L is equal to 1 is P orbital. L is equal to 2 is D orbital. L is equal to 3 is P F orbital. Okay, Nandi? This is the now the main significance of the azimuthal quantum number is how to find that, how to discuss that. The main significance of this angular momentum. Significance and the shape of the subshell. The main significance of this angular momentum quantum number, shape of the subshell. Shape of the subshell. The main significance of this quantum number is the shape of the subshell. Main significance, shape of the subshell. Now N is N values. N values. L values. L values means L is minus 1. N minus 1. L values L is equal to. Next, shell, subshell, shape in it. Now N is equal to 1, L is equal to 0, subshell S subshell, shape spherical, shape spherical. 2, 1, P subshell, dumbbell. 3, 2, D subshell, double dumbbell. And 4, 3, F, twisted or four-folded. Or complex. Okay, these are the main features of azimuthal quantum number. And the main features of azimuthal quantum number, like this. Okay, Nandi? Next, third quantum number, magnetic quantum number. Third quantum number is magnetic quantum number, denoted by MS. Denoted by MS and small ms, like this, and proposed by Lande. Proposed by Lande. And these values are depends on ML values. Sorry, ML and ML values depends on L values. Okay, Nandi? The total ML values are L is equal to total ML values. ML is equal to 2L plus 1. 2L plus 1. So the ml values are minus L, comma, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, and so on, plus L, up to plus L, include 0. Simply there are minus L, 0, plus L, ml values. Okay nandi, these are the ml values. So these are called integers also. These are called integers. ml values like that, integers. ml are like integers. Principal number values natural numbers like Lie numbers, and angular momentum numbers like whole numbers, and magnitude number like integers. Okay nandi. Next, this is the total ml values indicates the total ml values indicates the number of subcells are present in shell. The number of subcells present in a shell. Okay, like for example, the number of subcells present in a subcell. Like for example, the subcells are the cells. Sorry, number of subcells present in number of orbitals present in a subcell. Number of orbitals. Number of orbitals present in subcell. This is the correction. Sorry. Okay. For example, look at here. S, P, D, F. In S in subcell, one orbital is there. P subcell, 3 orbitals are there. And D subcell, 5 orbitals are there. And 6, F, 7 orbitals are there. Okay, nandi? Like this. S, 1 orbital, P, 3 orbitals, D, 5 orbitals, F, 7 orbitals, like this. So the total ml values indicate the number of orbitals present in subcell. The number of orbitals present in a sub. This is the number of orbitals present in subcell. Now, how to discuss about the number of orbitals present in the number of electrons. Now, the number of electrons present in subcell is 2 into 2l plus 1 formula. 2 into 2l plus 1. 2 into 2l plus 1. Okay, nandi? If L is equal to 0. L is equal to 0. If L is equal to 0, ML is equal to 2L plus 1. 2L plus 1. Now 2 into 0 plus 1. So it means 2 into 0, 1. It is no splitting. It means it is 1. So that is 1s. That is s sector. That is s orbital. 0 splitting. Like this. 0 splitting. It indicates 0 splitting. So now we have discussed about how many number of electrons. In L is equal to 0, number of electrons are present in subcell 2 into 2L plus 1 electrons. Now L is equal to 0. Now L is equal to 0. Now L is equal to 0. It is substitute here 2 into 2 into 0 plus 1. Now 2 into 0 plus 1. 2 into 1, 2 electrons. So L is equal to 0, which orbitals? S orbital. In S orbital, how many electrons are there? In S orbital, 2 electrons are there. In S orbital, in S subcell, in S subcell, 2 electrons are there. S2, like this. And L is equal to 1. Now 2 into 2L plus 1. So L value 1 is substitute here. 2 into 1 plus 1. L is equal to 1 means p orbital. L is equal to 1 means p orbital and 2 into 2 plus 1. 2 into 3. 6. 6 electrons are there. Now in p orbital, in p subcell, 6 electrons are there. Okay, like this. You have to find the number of electrons in subcell also by using the azimuthal quantum number. The main significance of the magnetic quantum number is orientation of the subcell. It means splitting it. Okay, now look at here. If is symbol. So n is equal to 1. N values, L values, ML values. Okay, Nandi? Principal quantum number, azimuthal quantum number, magnetic quantum number. The size and energy, shape of the subcell, and orientation of the subcell. Orientation means splitting it simply. Okay, look at here. N is equal to 1. Now to substitute, N is equal to 1. N is L minus 1. 2L plus 1 and okay, Nandi? Now L is equal to 0. Here L value 0, it is also 1. It means 0. N is equal to 0. Splitting, 0 splitting 1. S orbital. Like S orbital. There is no splitting. Next, N is equal to 2. 2 means L is equal to 1 only. L is equal to 1 only. It means ML is equal to 3. It gives minus 1, 0, plus 1. Simply denoted as like this. Px, Py, Pz. Next, N is equal to 3. Simply 2. Okay, Nandi? It is S orbital, it is P orbital, it is D orbital. L is equal to value. L value is 0 అయితే S orbital, L value is 1 అయితే P orbital, L value 2 అయితే D orbital. Now it is simply 5. It means minus 2, minus 1, 0, plus 1, plus 2. Like this splitting. Simply denoted as 1, 2, 3, 4. dxy, dyz, dzx, dx square minus y square, dz square. Like this, these are 5 orbitals. Like this. This is the splitting of the orbitals. Last one, 4. N is equal to 4, L is equal to 3, df orbital and 7. Minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Like this. 1, 2, 3, 4, 5, 6. Like this. 7 orbitals. So this is the splitting of the subcells. Splitting of the subcells like this. Okay, Nandi? This is the quantum number, 3 quantum numbers. Now discuss about final quantum number. Final quantum number and spin quantum number. Spin quantum number. It is denoted by MS, proposed by two scientists and one is Uhlenbeck and Goudsmith. Two scientists, Uhlenbeck and Goudsmith. Two scientists in it. By using this quantum number, you have to find the direction of the electron. Direction of the electron in orbital around nucleus. Around nucleus and significance. The spin direction to find the spin direction of electron. Spin direction of electron. Okay, Nadi? So here two spin directions are there. One is plus of, another one is minus of. Plus of indicates clockwise direction and it is anti-clockwise direction. Clockwise direction indicates upward arrow. Anti-clockwise direction indicates downward arrow. Okay, this is the significance of the spin quantum number. So now these are the four quantum numbers to find the exact position of the electron in orbit in an atom. Okay, thank you.